So, you want to know how to make a grappling gun for your video games? Well, you're in luck, because in this video, we're going to make one that is physically accurate. Most quick tutorials treat the rope like it's a big spring to save some time, but here we're going to do things the right way. I've broken this mechanic up into 5 levels. In level 1, we're going to focus on rendering the rope. In level 2, we're going to make an accurate rope swing. And in level 3, we're going to introduce the rope length and make sure it never exceeds its initial length. In level 4, we're going to make the rope reel in when the player is swinging. And finally, in level 5, we'll add a projectile launch and retraction, and also some sound effects. In case you don't want to follow along, there's a link in the description to the GitHub where you can download the code for free. This is going to be a step-by-step tutorial, but I am going to assume you have some basic C# programming experience. Without further ado, let's get started. So as you can see, I'm not starting off with a completely blank Unity project. Right now, I have a player that can look around and move around. That's pretty much it. This grappling gun right here is just for show, and there's this little box in the air that will be a little grappling point for us later, but it is literally just a box. As you can see, movement is very basic. It's kind of like press W, apply a velocity in the direction you're facing. I can hit spacebar to jump. I have the jump set pretty high right now because it's going to be a little better for us to demonstrate with a nice high jump. But anyways, now we're going to get into the coding. First, we're going to make a script called grappling gun that'll be responsible eventually for pretty much everything. For now though, we're going to use it to raycast out and get our grappling point to render our rope. So we're going to go in here and create a new script called grappling gun. Before we forget, we can go into our grappling gun and hit add component to add it. Now that I'm in Visual Studio, I can delete the 2 using tags, fix up my brackets, and delete the start and update function. We're going to start with 3 variables. One is going to be for a grapple distance, another is going to be a bool to see if we're grappling, and the last one is going to be a vector 3 for our grapple point. Now our grapple distance float is actually going to be a serialized field, so we can edit it in the inspector. Now in our update function, we're going to get some mouse input. So the frame we press our mouse button down, that's when we want to call our start grapple function. So we'll make that right now. And here's where the raycast is going to happen. But first we want to double check that we're not already grappling, because if we're already grappling, we shouldn't be able to start grappling again. So if is grappling, return. Next, before we start our raycast, we're going to get our hit information. So we're going to make a raycast hit variable and call it hit. In an if statement below, we're going to write physics.raycast. Now our first argument is going to be our origin. So the origin, if we think about it, we want to start by raycasting from the player's camera, not from the grappling gun, because the camera is going to be more accurate and it's going to be where the player is looking. The grappling gun is going to point in a slightly different direction, so it's just more accurate to do things from the camera. And if we see over here, the camera is the parent of the grappling gun. So for our origin, we can just put transform.parent.position. Next, for our direction, we want the same thing except the forward vector. So transform.parent.forward. Next up, we're going to out our hit information, so out hit. And finally, we want our max distance, which in this case is going to be our grapple distance. Cool. Now we're going to set our grapple point, and autocomplete is kind of telling me what to do here, and it's right. So grapple point is going to equal our hit.point. Next up, we're going to make sure is grappling is now set to true, because now we are actually grappling because we know we hit something. Now the way this grappling gun is going to work is once we press the mouse down, we're going to start grappling, and it's going to be held down for the entire duration of our grapple. Once we release our click, then it's going to end. So let's get that end logic in now. So down here is when our finger is off the mouse button. So we want to make sure is grapple is set to false. In here, this is where we want to do some of our physics stuff. But first, again, we do want to double check that if we are grappling. The physics stuff is going to come in level 2, so for now, we're just going to comment grapple. Now our grappling gun class is done for now. Definitely not fully complete, because we're going to come back to it a lot. So we're going to go back into Unity and make a new child of our grappling gun. And we're going to call it rope. Now we're going to try our best to position it right at the edge of the grappling gun's barrel, because this is where the rope is going to originate from. And I think that looks good. Now with our rope, we're going to add a new component called line renderer. Now a line renderer, in case you've never used it, it renders out a line. It's kind of in the name. Because we want our line to actually look like a rope, we're going to add a brown material to it and set the width to something like 0.07. Now we're going to make our new script called rope renderer, and then add it as a component right underneath the line renderer. After opening it up, we're going to delete our two using tags, fix our bracket, and then delete the start and update functions. So here we need references to our line renderer component and our grappling gun. So we're going to make two private variables. Next, we can use getComponent to set them up and start. Now, with this grappling gun reference, we also need to know about the grapple point and is grappling, but currently they're set to private. So right now, we're going to convert both of these into public properties. Now, back into rope renderer, we're going to make in our update function a check to see if we're grappling. If it is, then we want to make sure our line renderer is enabled. Next, we're going to set the first line position to the rope renderer's transform. Next, we're going to do the same thing, except for the grapple point. And now, if we aren't grappling, we should just disable our line renderer. Alright, so now we're going to go back into Unity and just disable our line renderer. Now, if we go to our grappling gun, we want to make sure we set a good grapple distance. For now, I'm going to set it to 100. It really doesn't matter though. So, if we hit play, we can now see when we hold down our left click, we get our rope. Right now, we can still move around and everything like that with it, and it'll still stay attached to the point that we hit it. But when we're grappling, we shouldn't really be able to move around like this. So we're going to fix that real quick. Also, if you want the little X in the middle of the screen, you can add it super easily by making a canvas and then a text option and setting the text to the letter X. So we're going to go back into our grappling gun class and make a new variable to reference our player movement. Now, because player movement is on our player, that's going to be the grandparent of our grappling gun. So in start, we're going to set player movement to equal our transform.parent.getComponent in parent. So in our start grapple function, right below where we set is grappling to true, we're going to disable our player movement by setting player movement.enabled to false. We want to make sure we re-enable our movement when we stop grappling. So in this else clause, we're going to say player movement.enabled equals true. Not tree. True. So now back into Unity, we can hit play and try it out. So before, we could move around and grapple at the same time, but now, once we're grappling, we can't move around anymore. Perfect. So now we have our rope and the basics of grappling set up. So in the next section, we can jump straight into making our rope start to swing. Now, before we start coding, we need to do a little bit of physics so we know exactly how we're going to make this rope swing. The best way to describe this would be like a pendulum, where we have a point that is fixed, and then we have a rope and some mass hanging from the end of the rope. The forces acting on this mass is gravity, pointing down, and tension pointing in the direction of the rope. We're going to say the rope makes an angle with the vertical called theta. Now, we don't have to worry too much about adding the gravity force to the object because, well, Unity does that for us. So our goal now is to figure out what kind of tension force we need to be adding. What we're going to do is split up gravity into two components, a radial component pointing this way and a tangential component pointing that way. These two make a 90-degree angle, which means this angle is theta. So our radial component is the force of gravity times the cosine of theta. Now, because our mass is going to move in a circular arc, this is going to be circular motion, meaning our mass is going to be accelerating with a centripetal acceleration of v squared over r, where v is our tangential velocity and r is the length of our rope. So our net force in the radial direction is going to be m ac, which is just mv squared over r. Now our net force in the radial direction is also split up into our tension and our force of gravity in the radial direction. So net force also equals tension minus force of gravity times the cosine of theta. Now our force of gravity is simply just mg, the mass of the object times the acceleration due to gravity. Now if you don't mind, I'm just going to erase this beautiful masterpiece for some more room. And now we can set these two equal to each other. So mv squared over r equals t minus mg cosine theta. Now we can simply add mg cosine theta to both sides and factor out an m to get our tension equaling mass times v squared over r plus g cosine theta. And this is the big equation that's going to make everything work. And honestly, if you wanted to know how to accurately make your grappling hook rope swing thing, you can use this and be done with the video. But as you can see, based on how much time is left, it's not exactly that easy. So let's get back to Unity. So now that we have all that physics stuff done, coding our actual rope swing shouldn't be that bad. So if we open back up our grapple gun script, we're going to start making our grapple function. But first, we need to figure out where we want to call it. Now, if you didn't know, you're not supposed to do any physics calculations in the update method. Even if we have a grapple function that's called there, it's still technically in the update function. So instead, we're going to use the fixed update function. So in order to call something here, down here, we're going to make a new boolean called isApplyingGrappleForces. And set it to true where our grapple comment is. And then false down here. So now in our fixed update, we can check if we're applying grapple forces, we want to, well, apply grapple forces. So we're going to make a new private void apply grapple forces, and then call that right in here. So now we need access to our player's rigid body. So right under where we get our player movement, we're going to say private rigid body, player rigid body. And set that up in start just like we did with our player movement. So down inside of our apply grapple forces function, we need to first get the angle theta. And in order to do that, we need to have the direction from our player rigid body to our grapple point. So we're going to make a local vector 3 called displacement and set it equal to our grapple point minus our player rigid body dot position. Now we're going to make our float theta and set that equal to our vector 3 dot angle and pass in our displacement and vector 3 dot up. Now we're going to get our centripetal acceleration, which, if you remembered, is v squared over r. And now we're going to make a vector 3 for our tension. And using that formula from earlier, we're going to set that equal to our player rigid body's mass times our centripetal acceleration plus our acceleration due to gravity, which is going to be physics dot gravity dot magnitude times the cosine of theta. Now it's giving us an error because right now this is a float and we want this to be a vector 3. So remember, we need to multiply this by our direction, which in this case is going to be the displacement dot normalized. Now finally, we're going to call our add force function on the player's rigid body, with tension passed in and force mode dot force as our force mode. Now, the last thing we're going to do before we test this out is in our start grapple function, after we do our raycast, we're going to set our rigid body's velocity to equal our vector3.0. So now we can go back into Unity and hit play. And as you can see, we can jump, grapple, and, well, we fall down on the ground. So let me see what we did wrong. Oh, yeah. So this function gives the angle in degrees, but our cosine over here gives the angle in radians. I don't know where it says it, but somewhere it says radians. So we simply just have to multiply this value by mathf dot degrees to radians. And now going back into Unity and hitting play, we can see our player swinging in a perfectly circular arc, just like a pendulum. And here's a quick little view from the side. Now, there are some issues with this. If we have the player jump, grapple, and then he happens to hit the ground, things don't work out exactly as they should. And if we start our player on top of the box, jump, and then grapple straight down, we're kind of just floating in the air for a little bit until we topple over and fall in a circle. Because right now, our rope isn't really acting like a rope. It's kind of acting like a solid rod that stays fixed the entire time, which is good when we're swinging like this, but not good when we're trying to make a grappling gun. But hey, if that's all you needed, you can stop watching the video and be done. But for those of us who are going to keep going, next up in level 3, we're going to work on this rope length thing. Alright, so in level 3, we're going to fix some of the issues we came across in level 2, and make our rope feel more like a rope and less of a big rod. So as per usual, we're going to open up our grappling gun script. Scroll up to the top because we're going to make some more variables. The first one is going to be a private float for the rope length. And the next one is going to be a bool to check if the rope is in tension. Now we're going to head to our start grapple function to set these two variables up. And just to make this class kind of make some more sense, I'm just going to move this function to right about here. So after our raycast, we're going to set our rope's length equal to the hit distance. But no, because remember, our hit distance is the distance from our camera to the hit point. And we want the distance from our rigid body to the hit point. So even though this would be super convenient, we're going to take our grapple point minus our player's rigid body position. And because this is a float and not a vector, we want to get the magnitude. And while we're here, we're going to get rid of this line setting the velocity to 0. Now, let's think about this other variable, the is rope in tension. So our rope is going to be in tension, meaning that it's being pulled if the rope length is less than the distance from our player to the grapple point. So in our update function, we're going to set our is rope in tension variable equal to our rope length is less than the grapple point minus the player rigid body dot position dot magnitude. Now, something kind of small that probably won't make a big difference, but it's a little bit more performant to use square magnitude than magnitude. And because we're squaring the magnitude here, we want to square the rope length. Next, we're going to head to our apply grapple forces function. And we're going to make sure we're adding our tension force only if our rope is in tension. And we're going to change in our centripetal acceleration, instead of our displacement.magnitude, we're just going to replace that with the rope length, because essentially that's all it is. And we can even change our displacement to direction and normalize it right up here. And then we can delete that dot normalized at the end of the tension calculation. Now, underneath our apply grapple forces function, we're going to make a new function called tug player. This function is going to get called when the rope goes from not in tension to when it is in tension, because that generally means there's some sort of tugging motion that happens. So this tug is going to be a direct change of velocity. So we're going to make our first float variable called tangential velocity and set it equal to vector3 dot project on plane, our player rigid body's velocity, and the plane normal to be the direction, which we know earlier is just the grapple point minus the player's position normalized. And this was actually supposed to be a vector 3. Next up, we're going to set our velocity to the tangential velocity. Set our tension variable to be true. And finally, manually set the position to where it should be, just to avoid some wacky stuff with the time steps going at high speeds. So we're going to set our player rigid body dot position equal to our grapple point minus our direction, which we can make this value right here our direction, multiplied by our rope length. Again, in theory, this line really shouldn't be needed, but it's mainly just for peace of mind. Now we're going to figure out when we want to be tugging on the player, and that's going to be when the rope is in tension, meaning our rope length is less than the distance between our player and the grapple point, and our velocity is pointing in the other direction. So in our fixed update function, after we call our apply grapple forces function, we're going to check if the dot product between the velocity and the displacement is less than or equal to 0, and if the rope is in tension. So if all this is true, then we're going to call our tug function. So now we can go back into Unity and test this out. As you can see, I can get a nice running jump, grapple, and then I can get tugged in the air and start swinging like a pendulum. Here, let me show you. I can get right underneath, jump, grapple immediately, fall, and then tug. We can also try getting some speed, jumping at an angle, grappling, and now we're swinging like a conical pendulum, where we're just kind of swinging in a big circle. Now I didn't do the angle perfectly right, so we're kind of dipping up and down, but it's whatever. If we go back and start on top of the box and try jumping straight up and grappling below, we instantly get tugged and pulled back down. And now we're pretty much done with our base swinging mechanic. So if you really didn't care about being pulled in towards your grapple point, you can end here at level 3, or skip right to level 5 to work on the projectile launch if that's what you're interested in. But anyways, let's move on to level 4, where we're going to work on reeling in the rope. Oh, and one more thing I quickly wanted to mention before we move on is that the only bad part about this right now is we don't render the rope slack very well. As you can see, if I jump up, grapple, I'm falling down, but it looks like I don't have a lot of rope left. But realistically, I do, and I'm in slack right now. It's kind of hard to wrap your head around, but eventually you'll kind of see it doesn't look the best. And that is a consequence of us trying to render the rope as a straight line, when, again, if it's in slack, it's not going to be taught like a straight line. Now, doing this accurately would make a long, complicated tutorial at least twice as long and probably a lot more complicated, because ropes don't hang in nice little parabolas, they hang in something called a catenary curve. So if you're trying to get it super ultra realistic, I'd recommend looking into that. But anyways, on to level 4. Alright, so we're going to get started in level 4 by yet again opening up our grappling gun class. Scroll up to the top because we got some more variables to make. The first one is going to be a serialized field for our reel-in acceleration. Then we're going to make a private float for our reel-in speed. And finally, a private bool called isReelingIn. Scrolling down to our fixed update, after we do stuff with the tug, we're going to update our rope length. First, we're going to make sure our rope length is at least 1.5 meters. And that we're reeling in. Now, this 1.5 meters is somewhat arbitrary, but I found it to be a good minimum length. And inside our if statement, we're going to add to our reel-in speed, our acceleration, times time dot fixed delta time. And we're using fixed delta time and not normal delta time because we are in the fixed update function. Next, we're going to subtract from our rope length our reel and speed times time dot fixed delta time. And if our rope length is less than 1.5, we're going to set reeling into false and force our rope length to equal 1.5. Since we're already in fixed update, I want to do a quick little correction to something in level 3. This should be less than or equal to 0, not just less than 0. But realistically, I don't think it will make too big of a difference. Now, scrolling down to our start grapple function, we're going to make sure our is reeling in is set to true, and our reel in speed is always going to start out at 0. Now we're going to head down to our apply grapple forces function, and now before we add the tension, we're going to check if we're reeling in. We're going to add a force equal to our mass times our acceleration times our direction, which remember is pointing up at our grapple point, which will accelerate us to the grapple point. And believe it or not, that should just about be it for level 4. So if we go back into Unity and change our reel in acceleration to something like 2, and if I hit play and then look at my box, go to grapple, we can see that we get reeled in and pulled up towards the box. Here, I'll show you by standing right underneath it. If I shoot my grapple up, we're accelerating upwards toward it at 2 meters per second squared. Again, I can get some sideways momentum, jump, grapple, and now I'm going to get pulled in towards the box. Because I'm accelerating in, angular momentum is going to do its thing and make me go a lot faster. Now with this reeling in feature, we can kind of just throw ourselves off the edge of the map, and we can be able to get back on because our grappling hook reels us back in. Let me see if I can grapple super far away, go all the way up, let go. Now I'm flying super high in the air, and that's all because of that acceleration part. So again, if you're happy with this and you don't really care about a launching projectile, you can be done. Level 4 is where the actual grappling hook mechanic is done. In level 5, we're going to add in a projectile that will launch to our grapple point instead of just our instantaneous raycast, and also add some sound effects. Congratulations on making it all the way to level 5, but stay with me because this last section is kind of a doozy. We're going to work on adding a projectile that gets launched with our rope, have it retract when we're done, and finally play some sound effects. The first thing we're going to do is make a sibling to the rope called suction cup. Now, I already have a mesh for this. If you want to, you can download it with the GitHub link, or you can just use a sphere. I'm going to set the scale for this to about 0.4 for all axes. Give it the proper material, and then line it up so it's sitting right about at the tip of the gun. I think that's good enough. Next, we're going to make a new script called Grapple Launcher, and then attach it to the suction cup, along with a rigid body, and a sphere collider. And you can remove the box collider too if you have it. Next up, we're going to disable our sphere collider, and then tick on is kinematic for the rigid body, and set the collision detection mode to continuous dynamic. Then we can open up our Grapple Launcher class. Delete the 2 using tags at the top, fix our brackets, and delete the start and update. Now we're going to add in some of our variables. We're first going to get a serialized field for our launch speed. Then we're going to make another serialized field for our max launch time. Next, we're going to make a private isLaunchedBool, a private float called launchTimer, and then private references for our sphere collider, rigid body, and grapple gun. Finally, we'll set up the last 3 variables and start. Now we'll save and head back into Unity and set up our serialized fields so we don't forget to later. For our launch speed, I'm going to set it to about 50 meters per second, and for our launch time, I'm going to set that to 1 second. Now going back into Visual Studio, we're going to make a private launch function. In this launch function, we're going to set isLaunch to true, our launch timer equal to our max launch time, enable the collider, so say sphere collider.enabled equals true, disable kinematic on our rigid body, and finally add an impulsive force in the camera's direction with the appropriate momentum. So that's going to be rigid body dot add force with our rigid body's mass times our launch speed times our direction, which in this case is going to be camera dot main dot transform dot forward. And finally, we're going to set our transform's parent equal to null. Now right below it, we're going to make another private function called endLaunch with a Boolean parameter called isLaunchSuccessful. Inside our endLaunch, we're going to set our isLaunched to false, disable our sphere collider, and finally re-enable our rigid body's kinematics. Now we're going to make our update function. And inside the function, we're going to check if we're launched. And if we are, we're going to decrease our launch timer by time.deltaTime. Then we're going to check to see if our launch time is less than 0. And if it is, we're going to call endLaunch with false passed in. The reason why our launch is not successful here is because we ran out of time for our shot and didn't hit anything. Therefore, our launch was unsuccessful. Then we're going to see if our mouse button gets released, so if input dot get mouse up, and if that happens, that basically means we just aborted the launch by saying we don't want to grapple anymore. So we're going to call endLaunch again with false passed in. Now after the update function, we're going to make another function called onCollisionEnter. The first thing we want to do in here is check to make sure we were launched. And if we were, we're going to set our object's position to the hit position. And we do that by saying transform.position equals collision.getContact and pass in 0.point. We're also going to set our transform's right to equal our negative contact.normal. This last line just makes sure the suction cup is pointing in the right direction. Okay, so we're done here for a little bit, and we can go back into our grappling gun class. Now we're going to do a bit of refactoring here, so just bear with me. But we're going to make a public enum called grapple phase. And we're going to make 4 phases. The first one is going to be a waiting phase. Our second one is going to be our launching phase. Our third one is going to be the grapple phase. And finally, for the fourth one, we're going to make our retracting phase. Now we're also going to make a public grapple phase property called current grapple phase. Next, we're going to go all the way up to the tippy top of the class and add a using for the system namespace. And then make a public event action with a grapple phase as an input argument. And we're going to call it grapple phase changed. Now we're going to actually delete our isGrappling property, because isGrappling is now just built into all 4 of these states. So we've got some cleanup to do. We're also going to get rid of this line for our grapple distance because we're not raycasting anymore. In the start function, we're going to set our current grapple phase equal to grapple phase.waiting. In the update function, where we call start grapple, we're now going to add an and to our if statement to make sure our current grapple phase is also grapple phase.waiting. We're also going to replace our call to the start grapple function with current grapple phase equals grapple phase dot launching, and then we're going to invoke our event. So we write grapple phase changed question mark dot invoke, and then we get to pass in our grapple phase. Now the argument to this function is going to be the phase we're transitioning out of. So for this case, it would be grapple phase dot waiting. Next up, we're going to put this whole if statement inside of another if statement to check if our grapple phase is in fact grappling. Next up, we can delete the innermost nested if statement and replace our setting of isGrappling equals false with setting our current grapple phase equal to grapple phase dot retracting. Then we're going to invoke our grapple phase changed event and pass in grapple phase dot grapple as our argument. Now I am just going to quickly rename this grapple to grappling to better fit with the other enum names. Now we're going to head down into our start grapple function, where we can delete the raycast and the guard clause. Now we're going to delete grapple point equals hit dot point because we don't have a hit dot point anymore, but we're going to fix this later, so keep that in the back of your head. Now we're going to also delete isGrappling equals true and replace that at the bottom by setting our current grapple phase equal to grapple phase dot grappling, and then invoke our grapple changed event with grapple phase dot launching set as our argument because we're transitioning from our launching phase. Now we're going to scroll up a bit. Above our start method, we're going to make a new public method called launchFinished. It's going to have a Boolean parameter called isLaunchSuccessful and a vector3 for our grapple point. Now we'll add a little guard clause to make sure we're in our launch phase. So if current grapple phase is not equal to our launching, then we will return. Next, we're going to set our grapple point equal to our grapple point, and then check if our launch was successful. If it was, then we're going to call our start grapple function. And if it wasn't, we're going to change our phase to retracting and invoke the event. Alright, we can now save what we have here and open back up our grapple launcher class. Here, we're going to make a new private function called onGrapplePhaseChanged, taking in a grapple phase as a parameter called previousGrapplePhase. Now we're going to subscribe this method to the event that we made earlier in the grappling gun class. And we do that by getting our grappling gun dot grappling phase changed and then doing the plus equals and then on grapple phase changed. Now, because we're subscribing here, it's generally a good practice to unsubscribe too. So we're going to scroll all the way down and make a private void on destroy. And then we can copy and paste our line and change it to a minus equals. And now inside this new method, we're going to check if our current grapple phase is launching and our previous phase is waiting. And if so, we're going to call the launch function. And then at the end of our end launch function, we're going to call our grappling gun's launch finished function, with isLaunchSuccessful passed in as an argument, along with our transform's position, because that is going to be where the grapple point is. Now we're going to head into our rope renderer class and make a private grapple launcher variable. And we'll call it launcher. In our start function, we'll set launcher to equal our grappling gun dot get component in children. Then we can replace our check to see if we're grappling with a check to see that we're not waiting. And then we're going to replace our grapple point to our launcher's transforms position. Okay, so I think we got launching all figured out. So let's head back into Unity and test it out. So if we aim at our box and click down on our mouse, we can see that it kind of just bounces off. Alright, so something's wrong. Let me double check the code. In our grapple launcher function, if we scroll all the way down to our on collision enter, we never end the launch even if we hit something. So we're going to call our end launch function, but this time with true passed in, because our launch here is successful. So now if we head back into Unity, we should hit play, and then aim at our box, click, and see that it sticks. It also pulls us in, but once we let go, it doesn't do any sort of retracting. It just stays there, kind of like it was during level 1. We can also test out our failure points. So if we hold down our mouse for over a second, it should immediately stop and then start retracting, but we haven't coded that in yet. And the same thing should happen if we let go prematurely. Perfect. Now, back inside of our grappling gun class, we're going to make a new serialized field. The first one is going to be a private float called retraction time. We're going to make another serialized field, but this one is going to be a private transform, and we're going to call it launcher transform. Then we're going to make a private vector3 called launcher offset, and a private float called retraction timer. In the start function, we're going to set our launcher offset equal to the launcher transform's local position. Now we're going to scroll down to update, and below everything, we're going to make a check to see if our current grapple phase is retracting. If it is, we're going to make another if statement to see if our retraction timer is less than our retraction time. And if it is, we're going to increment our retraction timer by time.delta time. After that, we're going to make a local float called t and set that equal to our retraction timer over retraction time. Then we're going to make a vector3 and call it final position and set that equal to our player rigid body's position plus our offset, our launcher offset. And finally, we're going to set our launcher transforms position equal to vector3 dot lerp, with our starting point being the grapple point, our ending point being our final position, and our parameter is t. And then if it isn't, we're going to call reset grappling gun. So we can scroll all the way down so we can make this function. We'll say private void reset grapple gun. Now inside this function, we're first going to set our launcher transforms parent back to our transform, which in this case, remember, is our grappling gun. Then we're going to set our launcher transforms local position back to our launcher offset. Then we'll set our launcher transforms local rotation equal to quaternion dot Euler with 0, 0, and then 90 passed in for the last one. We'll set our retraction timer to 0, our current grapple phase to waiting, and finally invoke the event. So now we can head back into Unity, and we have an error, which is because this should be grappling. Save, then we can head back into Unity and set up our serialized field. So our retraction time, I'm going to set to 0.2, and our launcher transform, we'll just drag in our suction cup. Then if we hit play, everything should hopefully be working perfectly. So I can launch, get reeled in, let go, and we're retracted. Then I can launch again, it retracts perfectly. So at this point, just like all the other times, you could be done. But next up, we're going to add some sound effects. This is technically still going to be a part of level 5, but that's what we're going to do next. So we're going to make a new class called Grapple Sound Manager and attach it to our grappling hook along with an audio source component. Opening up our Grapple Sound Manager, we're going to first fix our brackets, delete our using tags, and then delete the start and update. Then we're going to make 3 serialized fields for audio clips. One for our launch sound, one for our stick sound, and one for our reel-in sound. Then we're going to make private variables for our grappling gun component and our audio source component. And then use getComponent with them in the start function. Next, we're going to make a private function called onGrapplePhaseChanged with a parameter of a grappling gun dot grapple phase called previous phase. And just like with our grapple launcher, we're going to subscribe and start, and unsubscribe and onDestroy. Now we're going to make 3 more private void functions. In our play launch sound, we're first going to stop all the audio from our audio source. Then we're going to set our audio source's clip equal to our launch sound. Then we're going to set our audio source looping to false, and then we can play. We can do the same thing for the play stick sound too, just change from launch sound to our stick sound. Our play reel-in sound is going to be pretty similar too, except instead of looping for false, we're going to loop to true. And we still want to make sure we update our clip. Now in our onGrapplePhaseChanged function, we're going to check if our current phase is equal to launch and our previous phase is waiting. If it is, then we're going to play our launch sound. Then we're going to check if our current phase is grappling and our previous phase is launch. And if so, we're going to play our stick sound. Then we're going to check if our current phase is retracting and our previous phase is launching. And if so, we're going to play our reel-in sound. Finally, we're going to check if our current phase is waiting, and if it is, stop all the audio from the audio source. Now, we covered all of our bases except for when our stick sound ends. What we want to do is right after our stick sound ends, go straight into the reel-in sound. The way we're going to do this is by making a new private bool, which I'm going to name is waiting for stick sound to end, and set that equal to true after we play our stick sound. Then we can scroll down and make a private update function and check if we are waiting for our stick sound to end and if our audio source is not playing any audio. Then we can play our reel-in sound and set is waiting for stick sound to end equal to false. Now, at long last, we can save, head back into Unity, add in our sound effects, which you can get if you use the link in the description and download them off of GitHub, and then hit play. And then finally, we have our grappling gun that shoots our grappling hook, retracts. Well, our stick sound is being spammed, so let me check what our problem is.
2 hours later.
Well, that's embarrassing. I put the reel-in sound for the stick sound and the stick sound for the reel-in sound. So quickly fixing that, we should be able to hit play and see everything working perfectly. Perfect. And now, the last thing I want to quickly mention is that the grappling hook is sometimes a little bit glitchy when you're shooting it on a floor that has friction. It can easily be changed by changing your physics material's friction down to 0. But I do understand that sometimes that's not possible, so you might need to dynamically change your physics material while you're grappling, which is kind of annoying, but you just spent however long it was making this in the first place, so you can do it. Thanks again for watching the video, and hopefully following along. Remember, the code is in GitHub, and if you have any questions, feel free to comment down below, and I'll be sure to help you out. This was also the first time I ever made a sort of step-by-step tutorial video, something completely unscripted, so let me know what you thought and if I should do more stuff like this in the future. Thanks again. See you soon.